Good morning. For everyone who doesn't know me, my name is Matthew Harris. I'm from a company called Lenze. I work there as a business development manager, and I'm here today to release a brand new product to market. And there's a very short video just to start this presentation.
You think you know your conveyor's capabilities, inside and out? Think again. What if there was a drive roll that takes your entire process on a journey of endless opportunities? With a performance more powerful than any other MDR in the market. A true efficiency superstar, thanks to minimal friction losses and a resource-efficient design. Its gearless motor, providing you with maximal efficiency in operation and maintenance. Get ready to take your industry's leading role. It's time for the new motor-driven roller by Lenze.
So a nice dramatic video there for you all. So Lenze's MDR 0450, which we've released to the market, which you can see here. So generally when we're innovating and bringing new products to the market, we're trying to think outside the box and not do the same things that sort of our competitors are doing. So we took a standard motor-driven roller, which is we sort of had a gap in our portfolio where we didn't have a solution for this in a growing industry where we've seen, I believe, around 15% growth year on year for the last 4 years. So we took, like I say, the standard motor-driven roller, which has normally got a number of gear ratios integrated to cover a wide speed range and torque load. And we used what we're saying is a completely gearless design, a permanent magnet motor, which is based on a vernier principle. So we've removed the gearbox out of the roller, and we can still cover the complete speed range and torque range of all of our competitors with this single unit. So it gives you the high torque and the low speeds of a conventional geared motor, like I say, just with a single unit. We also, because we've removed the gearbox and we've made this motor so compact, we've managed to integrate the electronics inside the drive roller, and also the single speed variant, which means we can massively standardize. So you're not having a number of different gear ratios in the field. You can cover all applications with a single drive roller unit. So these are the key benefits of what the MDR 0450 are offering. We're saying from the testing that we've done, we're twice as powerful as standard MDRs that are on the market. We're giving powers of 57 watt at 24 volts, 115 watt at 48 volts. It's also incredibly efficient because we've removed the gearbox from the unit, so we've got a gearless design. We're saying it ranges anywhere between IE7 to IE9. We can't officially put it into standard IE regulations because that starts at 50 volts, but we've done a lot of testing, and I'll show you some graphs later on to see how efficient the unit is. It's also, again, because of the gearless design, it's very quiet compared to the standard competition, which again is very important for well-being of workers, reducing stress levels in the workplace. So this, I wouldn't say silent, but compared to other MDRs that are on the market, is very quiet. We already sort of mentioned the minimal variance. So for warehouses where they're using a lot of different rollers, a lot of different speeds, torques, whether they're moving different products, again, you can standardize on a single unit across the range. And again, standardizing even further, we also have a complete voltage flexibility. So the rollers will run off 24 volt and 48 volts. So we from an innovation perspective, we knew that we could do something with the 0450 roller, so we generated that technology, but this roller has what we call internally commutated electronics. So there's a number of standard control units that are on the market, such as the Interroll unit, Pepple and Fuchs unit. So we couldn't add value here, but we made our roller so that it runs off all of those technologies. We are also then going to bring an 0650 to the market, which is a digital, what we call a digital speed control. So we can aim that at more precise, more complex applications. So your standard analog here, which is aimed at accumulating conveyors, roller conveyors, standard conveyors that run in, for example, a ZPA mode, and then if you like, the closed loop positioning feedback systems where you may have merging cells or belt sorters and all of these things. And also the control system that we're developing is also going to integrate IO link, so which will allow us to bring data back in the application, so we can see what conveyors are running, how long they're running for, if there's errors, faults, and we can integrate that data into a higher level system. So in a world where we're talking more and more about digital solutions, this will open up that field for us. So this is what I was talking about with our drive roller being internally commutated. So it means that the Pepple and Fuchs Interroll Itadenki drives, for example, will work with our roller. There's also another number of competitors on the market where they have their electronics externally in the controller, so we wouldn't be able to work with, for example, a pulse roller control or so on, because then you'd basically have two lots of electronics in the system. So we say that this is that gives us the most flexibility in the market. So if we're extending existing lines that are already using Interroll control or using whoever's control, we can quite quickly and easily integrate our high efficiency MDR roller. So we partnered with Pepple and Fuchs on our controls. So this is a standard control that we'd recommend for our drive rollers. The reason being that because we have quite an extended torque range and extended power range, the Pepple and Fuchs gives us the control current that we need to achieve that performance. So we have a range of 3 controllers here. So we have a standard G20 ZPA controller, which is for a single fixed speed, where we can drive 2 rollers from a single control card. We then have a slightly more complex control card, which will run on an ASI system. So any bus over an ASI master, it's got 8 selectable speeds and ramps. And again, it will give you 24 volt or 48 volt control, depending on what torque range you need for that application. And then we have the G20 IO Link Pepple and Fuchs card. Again, so this will drive 4 MDRs. The logic's always in the main controller, but it gives us that voltage range again. And again, it's any bus over the IO Link master. So this gives you a bit of data about the performance of our rollers. So you can see here, sorry, just because we've got this permanent magnet servo control, we've got this complete speed range of anywhere from 0.1 to just over 3 meters a second. The biggest difference here being that we've got, so on a 24 volt system, we've got continuous torque up to a speed of 1 meter a second, and then we go into field weakening like a conventional motor. Whereas, again, a lot of the MDRs on the market don't allow you to run in this field weakening. So they run at the nominal and peak values for short periods of time. And again, the 48 volt roller just over 2 meters a second at full torque before we enter field weakening. So again, you've got the data up there in the top right corner. So rated speeds, rated torques, and efficiency values. So the comparison that we do is a lot of the MDRs in the market today work with what we call a block commutation. So normally an example of this means that it's quite slow to reactions on load change. So for example, if you were to grab a conventional MDR, it'd hold for a minute before it realized that, and then it'd try and work against the speed change. So with our sine, cosine, servo feedback, it means that whether you've got 5 kg parcel on there or 50 kg parcel on there, the speed is continuous, so it doesn't change under load. It's also, the speed control is very precise, and it's this control that allows us to go into that field weakening so we can get those peak torques, peak speeds out of the units. So a little bit about efficiency. So as mentioned, we can't sort of put these into standard conventional motors for IE regulations, but we took a comparison not only against standard IE regulations, but also against some of the market competitors. So on the left-hand side here, we've got sort of 4 optimal running conditions, if you like, of standard conventional MDRs. And although we're slightly less efficient during startup, we can see that we're running in this very blue area throughout, which falls in this up to IE7 values. So this on the left-hand side here is the voltage for 24 volts and 48 volts. Now, again, if you'd see a lot of our competitors' speed torque graphs, they'd all be based on different ratios, so you'd have much smaller charts, but you can see here we've got full speed range, full torque range, and that covers the complete range that's on the market. So although we came up with a specialist motor technology, we also looked at the industry standards for mechanical fixing. So from drive elements, you've got your standard sort of poly V-belt profiles, round belt profiles, tooth belt, and again, sort of standard surface finishes, whether they're steel or rubber coated or PVC. Standard conical units for turns on conveyors, and again, this sort of standard fixings, which is normally the 11mm hex spring-loaded or the M8 threaded connection. So again, to integrate as easily as we can into the market, we kept the mechanical side of it the same to prevent people having to make huge mechanical changes. Standard sizes as well, from 345mm up to 1.5 meters. And that's what we did. So yes, the gear motor, the technology is different, but the actual mechanical fixings of everything is the same as the market standards. So the big question is sort of, Lenze have brought this to market with all of these benefits against the standard MDRs in the market, but how can we make this price competitive? So with giving you higher power, more efficiency, low noise, a huge reduction in variance and standardization. And the main reasons that we can do that is because we can standardize on a single unit. We've removed a gearbox. There's 30% less material in these products. So because we're only producing a single unit, we can mass produce this product on a fully automated line. So we're very competitive against the market standards with all of these benefits. So for me, this is a great product that Lenze have developed and produced. I see a very positive future with this product. Thank you all for listening. I'll finish a little bit early. But if you need any more information, we're on stand 52 over there. Please come and talk to us. We're happy to answer your questions. Thank you.